Okay, let's see how to handle exception. So there are actually two ways that we can deal with exception. Well, the main one is try catch, and the other one is using throws. Let's go to the main one. The main one is where we really handle the exception and keep the program running. So it's try catch. And how it works is we write what we call a try block surrounding the code where we think exception may take place. And that can mean we can surround several lines of code. Right? This can be several lines. Alright? So once we surround a block of code that we think can generate exception when it runs, we write catch block after the try block. Alright? Where each catch block will deal with each type of exception. Okay? So the first catch will only deal with an error or an exception where it's this type. Alright? So catch block catch the exception or capture the exception object created in the try block. Alright? And then name it using this name. Alright, so the exception object has a name. And we can, use the name to refer to our call method later on. Alright, but we may not use the name at all. So it depends on how we want to deal with the exception. Alright, and the code for dealing with exception is written in the catch block. Alright, normally we reset the system somehow so that the program can continue running. Alright, because the very bad part of exception is that when it's generated, it stops our program. Alright? So we fix it by resetting the state of the program somehow to allow the program to continue running. And the program will continue to run after the last catch. So in this particular example, let's say the exception that takes place in the code here is actually this type. So what happened is the code will stop on the line that the exception takes place, and the control will jump right away to this catch block. Alright, the first catch block. And if this catch block can, catch that exception, and the type is the same as the exception that's actually generated, then the code for handling the exception is run. And after it runs to the last line and execute the last line of this catch block, the execution continue here after the last catch block. Alright? If the first catch block, if the exception takes place, the control jump to the first catch block. But if the first catch block does not catch the exception type that actually create here, right? If it's a different type of exception, the control will go to the second catch block and so on. Alright, and if this second catch block detect that the produced exception is actually the one here that it's looking for, then it executes and the code will then continue after the last catch block. Okay? So that's how try catch works. Alright? So, the other one is throws. That is when we don't want to handle the exception in our method, but we'll leave the handling of exception to the method's caller. So this way, we specify in our method that the method will generate this type of exception. Alright? And doing it like this will tell the compiler that this method passInt here will not have any catch block, say number format exception. But please allow it to compile. Alright? Allow it to compile even though it doesn't handle number format exception. Alright? So this is how we tell the compiler to let the error detection go, so that our program compile. Alright? But number format exception will then have to be handled in the method that calls passInt. Alright? Otherwise, if it is not handled there, then in that method, it will have to, declare the throws of number format exception as well. Okay? Right. So, that's the basic. Right? Now, I think we can see the example. Okay, so let's see an example where an exception actually takes place and we write try catch for the example. Alright? So let's see what happens here. So in this code, alright, we have an array with 2 slots. So the number of slots of S is only 0 and 1. See? And the loop for I is 0 until I is less than 3. That means the last value for I is 2, which is out of range. So this can cause an exception already. Alright? But initially, I will be 0. So in the first iteration, there is a divide by 0 here. This should be the first point where exception takes place in this particular example. Right? So when it runs, it will encounter divide by 0 here, and exception object will be created. And divide by 0 will create arithmetic exception. Right? So, the arithmetic exception will be passed to the first catch. Alright? The line here will not run. Right? The line here will not run because it's below the point where an exception takes place. Alright? The execution of the program will just jump out without executing this line. Alright? So, in the first catch, it checks the exception type of the one that gets created. If it's an array next bound, then it will execute the code for this catch. But as we know, it's not because it's an arithmetic exception caused by divide by 0. So the first catch will not run. The control flows to the second catch right away. And in the catch, it checks and it matches the arithmetic exception. So the object is passed to this second catch and rename the object AE. And from this point on, we can, do anything with AE. And E is the object that's created when divide by 0 takes place. It will actually contain the information of what causes it. Alright, so it contains some additional information that we can check. So we can do something like AE.toString print out. Alright, print out the content of AE. And we can do more things as well. Alright, but in this example, we only have 2 states. So the toString will print arithmetic exception divide by 0. Alright, after it prints, the execution will carry on after the last catch. That means the program will print out the word end before actually ending. Alright, so this is what happened. Let's see the actual run. Okay, so this is it. This is the actual program. Alright, it's the same. The print out after the exception point. Alright, the same. Array index of bound, array index of bound here, and arithmetic exception here, and print toString here. Alright, I also test AE.getMessage and AE.printTrace as well, but we will first see AE.toString first, right, and see what it prints. So, let's run it. Take a little time. Right. So it print toString, which is printing that it's an arithmetic exception, right? The AE, the arithmetic exception object that gets created is, well, it's toString method. Return this sentence. Java.lang.arithmetic exception divide by 0. And, well, once it executes this, it executes the statements after the last catch. So, it print end. Alright? So, that's toString for AE, but I can do other things. Let's see what it prints if I use getMessage. Let's lift this up. Alarm. Execute getMessage. So getMessage will simply return divide by 0. Alright, so that's less than toString. Alright, what about printTrace? printTrace is actually what the Java virtual machine will print if you do not handle this exception. So printTrace, let's see what it prints. So it prints Java.lang arithmetic exception divide by 0, and also where that divide by 0 is taking place, which you can, click and see that it's this line with 1 divided by I. Okay? So that's what happened with this example. Alright? This is divided by 0 in the first place. So it doesn't reach index outward bound. But what if we want it to reach index outward bound? I can, just change this such that an exception doesn't take place. Alright, and let's see if index outward bound is encountered, which it should, right? For each iteration, Si is set to normal value. But I will eventually go out of range. So let's see. Right, so we find and print 1 divided by 3. Since it's integer division, we print each time. We'll print 0 each time. And it will reach the point where Si exceeds the possible range, and it will jump. And in that case, it will match array index outward bound and print toString of the array index outward bound object. Alright, that we catch. So the toString will print this sentence here. Alright. Okay. And it still, even after it prints, the execution continue after the last catch. Remember? So, after the last catch, your execution go to here. So it must print N still. And so it does. Right? So that's this example. Remember, you can surround the code that you suspect exception to take place, and that block of code may have more than one possible exception. Okay? Right. Oh, that's it for this video.